So once you understand matrix multiplication compatibility, you need to observe a very important point here. It is existence of AB, existence of A into B does not imply the existence of B into A. Does not imply the existence of B into A. For example, if A is a 2 by 3 matrix, B is a 3 by 4 matrix. Now we can see that AB exists because this 3 number of columns in the first matrix and number of rows in the second matrix is equal, and you get a 2 by 4 matrix. Now for the same matrices, can you do B into A? If you take B first, this is a 3 by 4 matrix, A is a 2 by 3 matrix. So does BA exist? You can see that BA does not exist because the number of columns in the first matrix now is not equal to the number of rows in the second matrix. So AB exists but BA does not exist. So if we have a M by N and a N by P matrix, we have an M by N and a N by P matrix. So A into B exists. Now if you reverse the order, so you have B as N by P and A as M by N. So if BA has to exist, then this P has to be equal to this N. So if this number and this number are equal, AB exists. If this number and this number are equal, BA exists. So if AB and BA has to both exist, if AB and BA has to both exist, one should be of the order M by N, the other should be of the order N by N. If one matrix is 2 by 3, the other matrix is 3 by 2, then both AB exists as well as BA exists. Otherwise, only one of them exists. And even if both of them exist, AB need not be equal to BA. Because if A is a 2 by 3 matrix, B is a 3 by 2 matrix. AB is a 2 by 2 matrix, but BA is a 3 by 3 matrix. So these two cannot be equal. So in matrices, A into B need not be equal to B into A, even if I observe the order. So I really don't know right now how to actually multiply these two matrices. We're going to look into it. But even if you look at the orders, sometimes you can see that the order of AB need not be equal to the order of BA. Now let us try to understand what we actually do when we multiply two matrices.